my previous video, I discussed what moment of inertia is and how you can calculate it. I mentioned that it's a quantity that you'll often need to solve rotational motion problems. So in this video, I wanted to go over an example that incorporates this concept. Let's say that you're asked to solve the following problem. In this problem, a 5 kilogram pulley with a radius of 30 centimeters rotates with an angular acceleration of 15 radians per second squared from a force that's exerted on a rope wrapped around the pulley. There's a frictional torque of 1.2 Newton meters at the axle of this pulley, and you're asked to determine the torque applied by the rope. You'll also need to know that you can approximate the pulley as a uniform cylinder. The first thing that you should do in this sort of problem is draw a free body diagram. Because we know that the pulley can be approximated as a uniform cylinder, and because we have both its mass and its radius, we actually have everything we need to calculate its moment of inertia. Any reference table will tell you that the moment of inertia for a uniform cylinder is 1/2 multiplied by the mass multiplied by the radius squared. Plugging in 5 kilograms for the mass and 0.3 meters for the radius, we can find that the moment of inertia is equal to 0.225 kilograms times meters squared. In my previous video, I derived an equation showing that an object's moment of inertia is equal to its net torque divided by its angular acceleration. Because we know that the only torques in this problem are the frictional torque and the torque applied by the rope, we should be able to find the net torque and then calculate the torque applied by the rope. Plugging in the moment of inertia that we just solved for, as well as the given angular acceleration, we can solve for the net torque. This tells us that the net torque on the pulley will be equal to 3.375 Newton meters. Looking at the free body diagram, we see that the net torque will be equal to the torque applied by the rope minus the frictional torque. It's important to remember that a torque acting in the counterclockwise direction is considered positive. Plugging in the net torque and the frictional torque into the equation, we can find that the applied torque from the rope is 4.575 Newton meters. Because we know that this torque will be equal to the force applied on the rope multiplied by the radius of the pulley, we can actually now find the force applied on the rope. Plugging in the torque applied by the rope and the radius of the pulley into the torque equation, we can find that the force applied on the rope is equal to 15.25 newtons. I've labeled this force as force T. I hope that this video showed you how useful moment of inertia can be. Understanding moment of inertia will allow you to solve more complex rotational motion problems like these in a relatively simple way. If you still have any questions on this specific problem or on moment of inertia in general, feel free to comment below and I'll do my best to answer them. If you found this video helpful, please give it a like and consider subscribing to the channel for more fast physics videos. Thanks for watching.